Started on. Okay, is it visible, the screen?
Yes, sir.
Yeah, okay, fine. Then yesterday, I think, yeah, we have seen this, right? Just I will go through. By the time your friends will come and join, so that will be better. So, three coplanar forces. We are seeing only plane only. Till now, we didn't move to space. Okay, so only on plane only we are considering all the forces. So we have come across different forces, and then how to find the unknown force acting with some angle. Okay, so we have substituted. If suppose the resultant is acting along vertical axis, then obviously summation of all the horizontal forces will be equal to 0. That's only I said yesterday. Similarly, if the resultant is acting on a system along with horizontal, okay, then obviously all the vertical forces will be 0. Okay, so that is the conditions what we have seen, and then we have calculated one problem like this. Okay, hey, is it okay that I am giving you notes and then how we solved in the class? This is okay, right? Or you want something else?
Yes, sir, this is okay. This is fine.
Okay, so
This is fine, sir.
Yeah, that's only I have made two things. One is like notes, another one is how we solved in the class. Okay, and whenever you are taking, a very important thing is the positive sign and negative sign. Whatever method you want to follow, you follow. Okay, but be clear in that particular method. Okay, that's only I want to convey to you. I am not going to check whether you are following whatever I am teaching or whatever you are going to do. I am going to finalize your marks or whatever evaluation that is based on our answers only. So method, whatever method you are feeling, please go ahead with that. Okay, don't change because I am teaching in this way. Which one is easy for you, please go there, because the final thing is you have to understand the concept. That is very important. After that, then step by step how you have to solve, I explain. That is totally 4 plus 1 final one. In fifth step you will get the answer. After doing that, I told you one small thing, that please make always the answer in a graphical note, so that I can understand that you have understood the concept. So I will be more happy. That will be well and good. Even when you are saying your answers, these kind of pictorial representation, definitely it will impress anyone. Even if you are going for a job or anything, means you are more clear on concept, they will understand. Okay. And next one is, we have seen another one where the negative direction of y-axis is given, and then here instead of angle, slope is given. Okay, I think one of your friend did very well yesterday, I think so. I have put it in the group also. If you are that much clear, please go ahead with the direct method. Okay, I think Dhanush, right? Dhanush, I think so. Okay, so like that you can proceed. And then again, I want to say to you that please concentrate more on the sign. That is very important. So if you are not clear with the sign, then it will create a problem. Okay, and one by for others, it is not about others. For better understanding, I have taken all the forces and then I have explained how to calculate the angle. And some of our friends also helped us to calculate the angles clearly. And then we have made this particular diagram. Okay, so this is the one I said. If you want more clear about the concepts, so please go ahead with this particular type of thing. Once you have calculated all the angle, okay, then you will be more clear on what you have to calculate. Okay, that will be better. That's what I said. And after that, again we have gone through all the first step. There is summation of horizontal forces and vertical forces. And then vertical force, very important thing I said, that the negative sign you have to put because it is acting towards down. If you are making small mistake in this, then the entire problem answers will be wrong. Whatever methods you follow, that is correct. Okay, but the answers will be wrong. And finally, this one I think so. At last I explained. Some of you might have left the conversation because of your classes. Okay, so this one I said again. When you are finalize the answer, you have to draw like this, and you have to say that the force is acting on the fourth quadrant. This will give a clear idea about that you have understood the concept, and the P the given is acting on the fourth with an angle of 78. Everything. Okay, and I have given the summation of vertical forces because it is acting on towards down, so I have given down, and you can see that because the vertical force is acting on here, and then you can see the sum of the horizontal forces are 0 also I mentioned along x-axis. Okay, so like this, if you are giving, it will give a clear thing. Forget about these things. These things I explained by myself. Okay, so these two are important. That is H and then V. So by seeing itself, I will understand that the resultant is acting along y-axis. Okay, that's the thing. So after that, now we are coming. Okay, I need some of your friends to help me. Good morning, one and all. Did you come? Only 60. What happened? Always 8 people are not coming. Okay, fine then. Whoever is going to switch on the camera, I'm going to ask questions to them only. Okay. Manya, okay, you tell me what is the triangle law of forces. Can you explain? Are you getting me? Is the screen is visible?
Yes, sir.
Yeah, please can you explain triangle law of forces? A brief about that. Okay, who is going to explain? Any volunteer? Manya, are you hearing me?
Sir.
Yeah, okay, fine, boy. I think she's not audible. I think. Yeah, you please.
Yeah, if we take the
Jasmine, please open your video. I want to see your face. Yeah.
yeah
Me, sir?
1 minute. Who is going to explain? Kedar or Jasmine?
Yes, sir.
Kedar, yeah,
Kedar,
please.
sir.
Yeah. Sorry, boy. Yeah, Kedar. Yeah.
Can you see me, sir?
Yeah. Nice to see
Yes, sir.
you. Yeah. Yeah. Tell me, boy.
If the triangle of law of
Yeah.
vector
Yeah.
is,
Step by step, shall we go? Step by step. Yeah. Tell me, boy.
if two adjacent sides of a triangle are the two vectors, the force vectors.
Okay, wait. Okay, wait.
Yeah.
See here all the guys, the P is one and the Q is another one. Yeah, okay, now you can see.
Sir, I'll just leave the meeting and come in a minute, sir, because for me it's breaking.
Yeah, please.
Yeah.
Yeah, Kedar, yeah, now you can explain, Kedar, no problem. Yeah. If two forces.
If two forces are like represented by the two adjacent sides on a triangle.
Very good.
The third,
1 minute.
Yeah.
1 minute we will explain, okay? We will explain to our friends with you. So two, as you said, P and Q. Very good. After that. Yeah.
Then the third side will be the resultant vector of those two forces.
Very good. Okay. Whatever you said is good. Okay. Now you can switch off the video. No problem. So now, as like Kedar said that he explained well. Thank you, Kedar. Okay. One is, these are the two sides of the triangle. Okay. And the third one is the resultant, as he said. Okay. So as per in engineering mechanics, the definition now, definition is, please take down. If two forces are acting at a point, yeah, please. Am I audible? Is it clear?
Yes, sir.
Yes, sir. It's clear.
Yeah.
Yes, sir.
Yeah, now you take down, if two forces are acting at a point, that is, I am taking this as a point, okay? The two forces are P and then Q are represented by the two sides of the triangle, okay? Are you getting? So two sides, this is one side and this is another side, okay? Please take a note, taken in order. That word is very important when you are writing the definition. That is, it is in the same line. You can see the arrowhead, one, and the same thing in this direction. Are you getting? It is taken in the same order. Then their resultant force, that is very important, that is this particular force, resultant force, this particular force, okay? Are you getting? Represented by the third side of the triangle, but it should taken in the opposite order. Please take a note of this. This is the thing. The arrow, okay? Actually, when I'm drawing a triangle means how it should be? It should be like this. After that, it should be like this. Arrow should be like this. Am I right? But in triangle law of forces, okay, this is these two are in order. That is P and Q are in order. But the resultant when you are taking, this is the R, it should be in the opposite order. Please take a note of it.
In the opposite order. Okay.
Yeah, exactly. Okay, that is very important when you are explaining about what? Triangle law of forces. Yeah? Yeah, 1 minute.
Sir,
Yeah. Tell me what.
Sir, I have a doubt, sir. I have a doubt,
Yes.
sir.
Yes.
Can you go to, sir, then in the above diagram, the first diagram, where you mentioned Q and P, no, sir? The blue
Which one,
color,
sir?
which is
Which
kept.
one, Dappa?
The
Which
first one, sir. In this page itself, sir. In this page, sir.
Yeah, tell me,
Don't
yeah.
scroll up.
Mm-hmm.
The first one, the blue color.
Yeah,
Then
yes.
what would be the resultant, sir? Which direction would it go?
No. This is for understanding purpose. I have drawn.
Actually, localize the vector, sir.
Okay,
If the
Exactly.
vector is shifted parallel, direction is unchanged.
Exactly, boy. What's your name?
Stevenson, sir.
Yeah, Stevenson. This thing actually, who asked the question actually? Stevenson is good.
Sir,
Who answered?
Jasper asked.
Yeah. No, this one we have already seen in the parallelogram law of forces. What we can do,
Okay.
I said that. The first definition itself. Okay. This force can be replaced. Okay. We have seen this.
Okay. Yes, sir.
Yeah.
Yes, sir. Got it, sir.
Okay, guys. So we will move to the next one. Very good. Thank you to our what is the Kedar. Okay. Very nice explanation, and our friends also. Sir, 1 minute. You want to write it down?
So just a minute, sir.
Yeah. Sorry. Yep. If I am drawing a triangle, are you able to get me? This is one. Okay. Are you getting the direction?
Yes, sir.
And the next one is, this should be the direction. Am I right?
Yes, sir.
And from here only I have to draw a triangle. Am I right?
Yes, sir.
Then the order should be like this actually. Am I right?
Yes, sir.
But in triangle law, this and this will be in the same order. Are you getting?
Yes, sir.
Only the diagonal will be, the resultant should be in opposite order.
Yes, sir.
Are we clear
Got
now?
it, sir.
Yeah.
Yes,
Okay. Okay, guys, and yeah, tell me.
So how did you take the Q to the other side in the second diagram?
It's a parallelogram law. What happened? This one.
Okay. Yeah, okay. You made it the other side.
Fine. Just now our friend also explained very well actually. So this is your hard question. Please solve and post it in the group. Whoever is going to post first, they will get 10 out of 10.
Fine, sir, no problem.
Yeah, till now I noted down 15 chocolates. I have to give it to different people. One fellow got 3, I think so, more than 3. I will see that. Shall we move to the next heading? That will be well and good.
Wait.
Sir, 1 minute, sir, 1 minute.
So solving.
Very simple. 2 equations you have to solve, and then you have to find out the value of N. Okay. One is 90 degree. Please make a note of it. Don't forget this. This is how much?
That's 90.
Yeah. And this one is 60. So sometimes they won't give angle. They will mention at right angles. Okay. So we are moving to very important topic, equilibrium. I already defined. Okay.
So is it
Yes.
next module?
No. The same topic, but we are going further. Instead of calculating resultant, we are moving to the equilibrium. We are in the first module only till now. Okay. So
Okay, sure.
equilibrium I already explained. With the action of forces, if the particle does not start moving, I told you already, if it is fixed, or the particle, our friend is also asked, okay, moves in uniform motion. I told him during the law itself, it should be a uniform motion. Okay. Then the particle is said to be equilibrium. Okay. Our friends are ready. I'm going to ask few questions.
1 second.
Who is there in online? I told 3 members.
Yes, sir.
Yes, sir.
Yeah. So what is the meaning of this equilibrium, boy? What will happen the forces acting on this equilibrium of a particle? Will the resultant will be 0?
Yes, sir.
Yes, sir.
Yeah, please make a note of it. So as per our friend's suggestion, I am going there. So whatever forces that is resultant is acting on that particular particle, okay, will be 0. That is based on our friend's suggestion. If it is in equilibrium, the resultant will be equal to 0. Any other point you want to convey apart from resultant is equal to 0? Any other point? Am I'm asking our friends. Any other point you can add it to this? Not only these two, you can add some more points also. Please take a note of it. Summation of horizontal forces is equal to 0 and summation of vertical forces also should be 0. These 2 points you add it with R is equal to 0. So these are the 3 major things you have to remember. This is 1, this is 2 and this is 3. Okay. So now we are going to study equilibrium of a particle. The set of forces where resultant is equal to 0, those forces are called equilibrium of forces. This is very important. Okay. So the set of forces where resultant is 0, please underline that particular thing. Okay. The resultant is 0 or called equilibrium of forces. Is it done?
Yes, sir.
Yes, sir.
Yeah. Right. The thing is, very important concept is, so I am having different forces F1, F2, F3 with the different angles. See, theta 1, theta 2 and theta 3. Are you getting? So this one can be represented as with the resultant and the resultant inclination. Are we clear about that? So 3 forces are acting. This can be equal to a single force that is resultant with resultant angle. Okay. Now my question is, there is a force which is equivalent to the resultant, okay, and acting in the opposite direction. What is the name of this force?
Equilibrium. Sir, reaction force.
It's a normal reaction.
Okay, one is reaction force. Okay, that is coming in beams and other things. That is good. In this condition, this is making, so try to understand, if I am applying a force which is equal to the resultant, okay, definitely this particular force, listen again, if I am applying a force which is equal to the resultant,
Equilibrium.
very good. I will complete the definition, boy. Okay. If I am applying a force which is opposite to the resultant, equal in magnitude, this force will make the entire system to equilibrium. Am I right?
Yes, sir.
Any doubt in that?
Yes, sir.
Okay. Okay. So now that particular force is called, take down, equilibrium. Please take a note. So equilibrium is equal to the resultant force in magnitude and direction. Please take a note, magnitude and direction. Another one also you have to make it down, collinear but opposite in nature. That's all. These words should be there for getting 2 marks. Again, can I repeat?
Yes, sir.
So the equilibrium is equal to the resultant force in magnitude and direction, collinear also, okay, but opposite in nature. Okay, you can add a point that this will make the entire system as equilibrium.
Sir,
So if suppose in problems, instead of asking resultant, if they are asking equilibrium, what do you have to do?
Resultant force equals to 0.
Resultant force.
We need to
of
change the sign, sir.
Very good, boy. You have to change the direction and you have to change the values. Okay. 1 minute, I will
You
explain.
mentioned that it has the same direction as the resultant force.
1
Yes,
minute,
sir.
I'll tell you.
Isn't
I'll tell
it
you.
yes, sir.
opposite,
Direction.
sir?
Opposite direction.
Yes, sir. Direction.
Opposite.
should be
1 minute.
opposite,
1 minute.
right?
1 minute, boy. See here. This is the system, for example. We got the resultant here, for example, with alpha. For example, 10 Newton with 10 degree. Okay, the equilibrium should be same magnitude and direction. Okay, but in opposite in nature. Try to understand. Okay, opposite in nature. That means it is going from the particle, from away of the particle it is going. Here also it is going away of the particle. That is the meaning of direction. Please take a note. Okay, and the equilibrium will be equal to 10 Newton and the angle should be how much? 10 degree. So if suppose they are asking resultant, this is your answer, you will get mark. If suppose they are asking equilibrium, you have to remove this and you have to draw only this. Got it?
Got it, sir. Understood.
Direction is opposite.
Yes, sir.
Again, I am saying that please take a note of it. The thing what I am mentioning here, direction is, okay, from the particle it is going away, that is the direction. This is resultant. From here the equilibrium also going away, that is the direction. Opposite in nature will give the entire answer to you. Got it?
Okay, sir.
Yeah, yeah. Concepts are very important. Okay, so now as our friend said they want to take a note, please take down the conditions of equilibrium as I said. Oh, sorry. Is it clear now? Is it visible? The screen is okay?
Yes, sir. Yes, sir.
Yes, sir.
So now you take one by one the conditions. I am feeling that what kind of jalebi I am making on the screen. Okay.
That's fine.
I think it's okay. I think so. Okay, instead of going with the PPT. Personally,
Yes, it's better, sir.
Yes, sir, it's better.
Sir, if resultant is plus 10, then equilibrium will be minus 10.
which one? Tell me. Can you please tell me?
Sir, if it is positive value for this the resultant, then what will be the value for the equilibrium?
Yeah. Very good. Very good. Okay. If you suppose you are saying in numerical, if you want to write the answer, 10 Newton. Okay.
Yes, sir.
Got it?
Yes.
Sir, equilibrium will be minus 10.
Yeah. Exactly. Got it?
Yes.
Yes, sir.
1 minute. Sorry. Yeah. Is it okay? See here what I wrote. Okay. Next one. We are moving to one important.
Sir, 1 second, sir.
Okay. You want the previous screen?
Yes, sir.
Okay.
So,
Okay. 1 minute. Yeah. Is it okay?
yes, sir.
Yeah. So now I have to call some of our friends actually. Okay, next one, I need some friends. Okay, whom I can call. Okay, already I called one fellow. He didn't answer me. Okay, Anup, are you there? Anup Singh? Anup? It's not there.
Sir,
Anup, are you
sir,
there?
I'm there.
Okay, very good.
Just a bit network.
Shyam is there, I think so. Okay. Anup, whether your network is okay?
Now it's okay, sir.
Okay, then fine. Joel, are you there?
Yes, sir.
Okay. Joel and Anup are going to help us this time. Yeah. So now, next one is, oh, I have shown the answer also. Then, okay, find it. Yes. Okay, find a boy. We will go one by one. Okay. There is one particular thing. Joel, this one you take it out. So try to understand that a particle is here and the 3 forces are acting, P, Q, and then S. Okay. So these 3 are, please take a note, 3 coplanar forces. Okay, that is acting at a point. Please understand that whether it will be in equilibrium. Joel.
Yes, sir. It can be in equilibrium.
It can be very good. That is the answer I want. Can be equilibrium. Okay. Now, then each force is proportional to the sine of the angle between them. Any doubt in this, Singh? Singh, are you there?
No, sir.
Okay. Are we
Sir,
clear
I'm there,
about this? Okay. Are you getting this? This one you already studied. What is that?
Sine law, yes, sir. Studied, but
This is the
What is the
sign
name
law,
of
can't
it?
comprehend the line.
Lami's theorem.
Okay. That is good. Okay. Now listen here. Whether I have wrote clearly, can you say? P, okay, listen here, the force is P and then the sine of the angle between the other two. So this is P, the sine of the angle between Q and S is alpha. Is it correct?
Yes, sir.
So sine
Yes,
alpha,
sir.
is it correct?
Yes, sir.
Okay, fine. Now sing again. So the force is Q now, the Q, okay? The sine of the other two, sine of the angle of the other two, S and P is beta, am I right?
Yes, sir.
Yeah, okay. Any doubt in this?
No, sir.
No, sir. No doubt.
Yeah. Just a minute, I am getting some noise, okay? Sorry for this. Okay, fine then. The next one, last one is, you are having, yes. So the sine of the angle between the other two, P and Q is gamma. Is it okay?
Yes, sir.
This law is applicable only when it is in
Equilibrium.
Please take a note.
Equilibrium.
Yeah, don't substitute in other condition. Please take a note of it. Anup and Joel, are we clear? Hey, these things, actually we have a lot of problems in Lami's theorem. We will do. Okay, otherwise I will give it as a tutorial. We can solve it. I think tomorrow we are having class called tutorial. Am I right? Yes or no?
Sir.
Yes.
Actually, we don't know that concept, sir.
Okay, you want only problems, huh?
Yes, sir.
Okay, fine. A day, all 68 are there. Okay. Anyway, we will go one by one. So, shall I move to the next slide?
Yes, sir.
Sir, what if there are 4 or more forces?
You cannot use Lami's theorem. You have to use the equilibrium conditions. What I have said. Very good, boy. What's your name?
Kedar Kulkarni.
Hey, Kedar. Very good. Nice question, boy. That is great. Okay. Even if two forces are there, what will you do?
The normal bifurcation, sir.
Equilibrium condition. Yeah, exactly. Just now we said na conditions for equilibrium. Those things you have to use.
Okay, sir.
Are we clear now? What are the conditions? Resultant is equal to 0. Summation of all the horizontal forces are equal to 0. Summation of all the vertical forces equal to 0. Okay. Yeah. So now I am coming to that. Okay. So please take the problem. We will solve. It is up to you. Okay. I want Kedar. Kedar, are you there? Kedar?
Sir, Kulkarni or me?
Kulkarni. Okay. Who asked the question?
Me, sir.
Kulkarni, right?
Kulkarni.
Yeah, Kulkarni, please solve this problem by equilibrium condition. All other friends can solve by this problem in what condition? What condition we can solve? Three forces equilibrium.
Lami's theorem.
Lami's theorem.
All our friends will solve in Lami's theorem. Kulkarni will solve in equilibrium conditions. Okay. The thing is, very important thing is, okay, I'm giving you a few minutes time, then I will start explaining. With this, we are winding up today's session. Okay. The thing is, whenever you are drawing any kind of free body diagram with forces, please make a note that there should be x-axis, there should be y-axis. This is F2, which is making an angle of 30 degree, and this is your F1, which is making an angle of 60 degree, and this is your F3, which is making an angle of how much? Actually wrong. As an engineer, I should not put
90 degree.
Yeah,
90 degree.
As an engineer, I should not put like other graduate. I have to put exactly. Okay. Are you getting? So now, definitely, I am not going to consider this force when it is coming for horizontal. Okay. Are you getting? When I will consider this force only in vertical direction, not in horizontal. This is for Kulkarni. All others, please substitute. What is the formula? Can you tell me? F1 by? Okay, I'll take something. Lami's theorem, what is the formula? Can you tell me?
F1 by
Sine 120.
Okay, I will write here. Okay, I will write F1 by. So F1 is this. This entire angle I need, right? Am I right?
Yes, sir. 30 plus 90.
So 90 plus.
F by sine 120.
So sine 120. Please take a note, guys. All of you will forget that 90. Then it will create a problem. 120. Okay, next one. F2 by. F2 is here.
Sine 150.
Opposite to is these
Sine
things. Yeah. 90 plus 60. That is equal to 150. Please listen. 150. The last one, F3. This is F3. The opposite these two. This force I want.
990.
Yeah, already 60 gone. Yeah, already 60 gone. Already 30 gone. So 180 minus 90, I will get
90.
90. Very good.
Sine 91.
Yeah, sine 90. So calculate what is F2 and F3. Easy. How to calculate?
F2 is 144.33 Newton.
Sir, I'm
Very
getting
good. Very good.
145.3.
288.67 Newton.
Very good. Very good. Very
So
good.
144.3 Newton.
144.34 Newton.
Okay, 1 minute. 1 minute. 1 minute. I will write it down. Then we can have a word with Kulkarni. Tell me
144.3
4.3.
Very good. 3 Newton. This is F2, right?
Yes, sir.
Yes, sir.
F3 is 288.67.
288.67.
7.
68. Okay, 7 I will take at present. Okay, fine. Kulkarni, are you getting the same answer or different?
Yes, sir.
Okay, fine. Then. Did you solve it?
Yes, sir.
So I don't want to say like that. Some of our friends will feel that he's simply coming and saying a problem. Only 3 of the students are answering and then he is leaving the class. It's not like that. So I solved before you by 2 conditions. Yeah, now you check it. Okay. So to others, please check this. I will minimize the screen. So one is I solved by Lami's theorem. Another one is I solved by equations of equilibrium. Okay, so this is the Lami's theorem answer and this is equilibrium answer.
Sir, if you do without the Lami's theorem, the equation would be like this only, no sir. I'm saying the equation, can you say whether it's correct or not, sir?
Yeah, tell me the equation, Rabbi. No problem.
F1 sine 60 plus F2 sine 30.
Which one you are saying? Summation of all or horizontal forces and vertical forces? Which one you are saying?
Sir, horizontal, sir.
Yeah, horizontal you tell me?
Sir, vertical, sorry sir, I'm saying vertical.
That's only
sir.
I said,
vertical,
please go
sir,
with
vertical,
step by step.
F1 sine 60 plus F2 sine 30 minus F3 sine 90 is equal to 0, sir.
F3 da, no need of putting sine 90. Okay.
Okay sir, okay sir.
Fine then, next.
And then if we see for horizontal, F1 cos 60 minus F2 cos 30 and then 0, sir.
No, again you repeat F1.
F1 cos 60, sir.
It's a positive or negative?
Negative, sir.
Yeah, okay. Next one.
Then positive F2 cos 30.
Okay,
then 0 will be coming, sir, because 90 degree, no, sir.
That's all.
Then we can solve the 2 equations and find, sir.
Yeah, exactly. No, that don't equal to 0, boy. Please take a note. No need to solve. Please make it 0. Why we are putting 0? Because it is under equilibrium condition.
Equilibrium. We can find with the second equation, we can find F2 and substitute an equation 1 and find F3, sir.
Yeah, obviously. Otherwise, if you are substituting in both the equation, you will get the answer.
Yes, sir.
Yeah. Please, others, please make note of it. Are we clear about today's class?
Yes, sir.
Yeah.
Yes, sir.
Yeah, fine then. Boy. Okay. Please take down this. Next problem.
Sir, we have to solve now, sir.
I will say the steps. You can solve it later. Okay. Take down. The forces shown in figure are in equilibrium. Find the magnitude and direction theta of the unknown force P. So how many forces are here?
4.
I think I did not write the P.
5, sir.
5.
Yes, sir.
Yeah. Whether we can use Lami's theorem here?
No.
No, sir.
So when we have to use the Lami's theorem?
When there are 3
4.
When there are 3 forces.
Very good. How many forces are here?
5.
5 forces. So we can use the concept of equilibrium.
Yeah.
Sir, we can resolve and use Lami's, no, sir.
How da?
Okay, sir. Sorry, sir.
Okay. This is only the thing is 3 forces, and then if it is in equilibrium, we will get the relation between one force with respect to another 2. Okay. But if it is more than 3, then we will face a problem in that. So this one, what you have to solve? Summation of horizontal force equal to 0. Summation of vertical force is equal to 0. That's all. Okay. You can find what are the values. P, and then you can find out the value of theta. Listen carefully. The theta is entire thing. Okay. Are you getting?
30 plus
15 is
tan
a
angle,
long,
sir.
15
No,
Newton
no,
is a
no.
long
Together
axis.
only theta. Together only theta. Okay.
Yeah,
What
sir.
else?
Theta has the 30 degree, sir.
Yeah, theta has that 30 degree. Very good. Please don't add that 30 with the theta. That's only I want to convey.
So
Okay.
15 is a long y-axis.
Which one, boy?
15 Newton.
This is y-axis, boy.
Yeah, so 15 Newton is a long y-axis, no, sir?
Exactly. This is positive y. Very good.
Okay.
This is positive x. Okay, fine then. Got it? So can we solve?
So how is it 45?
Yeah, 45. That is 45.
How,
so
sir?
what? Yeah, I will give you some hints, okay? Here you will get one equation. Here you will get another equation. And you can divide 1 divided by 2 or 2 divided by 1. You will get theta. After that, substitute in any one of the equation, you will get P. Please take a note. Again, I will repeat. So summation of horizontal force equal to 0 will give you one equation. Summation of vertical force equal to 0, you will get another equation. And then 2 divided by 1 or 1 divided by 2, if you are going, I think summation of vertical force will come in sine theta. So you can make P sine theta divided by P cos theta. What is this? P
Tan theta.
tan theta. Not P tan theta, it's tan theta. Sorry, 1 minute. Digital world made me to learn so many things. Okay, one point of things I'm happy about digital world. Okay, so what you will get is you will get tan theta. So it's better you go with 2 divided by 1. Why I'm saying 2? Because 2 will have a component of sine, 1 will have a component of cos. Okay. After that, you substitute in any one of the equation this theta, you will get the answer. Okay. Any other doubt?
Sir, is the 45 degree given, sir, or?
Yeah, it's given. It's given, boy. I didn't.
Sir, that means theta is 15 degrees, sir.
I don't know. I didn't mention that. Wait. Very good question. I did not mention that this 25 and P is in opposite direction. No, it's
Okay,
not
sir.
right.
That's
Okay?
what I.
Yeah, very good question, boy. Very good question. Listen here, the 25 Newton and P is not on collinear. Please take a note of it. Is it okay?
Okay, sir.
Yeah. So your answers are, okay, I will wind up the session. I will show the answers alone. Please solve it. So your answer is 20.16 and 61.24. Okay.
No, sir. Both P and Q are coming complex numbers.
Are you sure that it is coming in negative?
Yes,
Yes, sir. 100% sure, sir.
100% sure.
Yes, sir.
What is the value I have given for?
Sir, if at 90 degrees, if you give it
Oh,
root
yeah.
15,
Got
you have
it.
to give it
Got
at
it.
root
No.
less
Yeah,
than
what
root
you have said is
22.0.
correct. Please make the second force as 20 Newton.
Then okay, sir.
Okay, sir.
Okay,
Fine.
we'll get,
Please
sir.
take
We'll
a
get,
note.
sir.
Second
Then
one
easy,
is,
sir. Sir, then we'll
second one
easy,
is
sir.
20 Newton. Okay, fine.
Sir, then we'll get 2 equations and just solve by elimination method and we get the answer, sir.
Exactly. You're right, boy.
Sir, is it root 20 or 20?
Root 20, boy.
Okay, sir.
Okay, so we will try it.
Thank you.
Thank you, sir.
Thank you, sir.
See you all. Bye.
Sir, yes.
Sir, is theta 61.21 degrees for...
The last problem, boy. 1 minute.
Yes,
Yeah.
sir, yes.
1 minute. Yeah, I think so, boy. 1 minute. Are you able to see the screen?
Yes, sir.
Yeah, 1 minute. I will. Yeah, 61.24 I am getting.
Okay, 24. And I got P as 20.18 Newton.
Yeah, very good. No problem, that is more or less same only, right?
Okay.
It's not a, yeah, very good.
Thank you,
Sir,
Yeah. Tell me, boy.
sir, what should we replace in that HOTS?
Which one, da? Which one I'm not getting?
Like,
instead of 25 Newton, root 25 Newton, go with 20 Newton. Got it? Okay, fine.
Sir,
I will share it in the screen. This one, boy. What is that in the group? In the group again, I will share it. Okay.
Okay, sir.
Okay. Bye. Have a nice.